Great. Can you guys hear me okay? All right, great. Again, the topic here is building a predictive pipeline to rapidly detect phishing domains. And I wanted to thank you for being here. Thank you for having me. Thanks to the volunteers and especially the audio-video team. They don't get any love, so. But again, my name is Wes Connell, and the research that I'm presenting today is a little side project that I had done in December. And I've already published my slides to the BSides scheduling website. And I've built a command line utility, and I've also got an IPython Jupyter notebook that's also published to GitHub, and I'm going to walk through some of that in this talk. And with that, we're going to do a little live demo. We're going to kick this off. This has all been Dockerized, so I have a Docker container that's listening to this feed of domains. So I'm going to go ahead and kick that off. And it's not a real software development project if you don't have awesome ASCII art. So we're going to let that run, and then we'll come back to it in 10 or 15 minutes. A little bit about myself. I run the security analytics team at PatternX. And again, the predictive model I'm presenting today is very simple. It's very straightforward. At PatternX, we've got predictive models that span multiple data sources and are looking at both spatial and temporal features, looking at time. So thanks to them for letting me be here and release this. They didn't have any problems with that. And I think with this upcoming week, there's going to be a lot of conversation about machine learning and AI and advanced statistics, among other things. And it would be nice to see vendors do a little bit more to kind of explain the independent variables that make this up versus having a lot of the discussion being it's magic, it's a unicorn, it's perfect, it's all that. So my background, I've always been a security guru. And fortunately, I got started at Northrop Grumman, and I immediately joined a research team where I was exposed to machine learning and intrusion analysis. And for me, a lot of the things that are second nature to security folks, they've never had exposure to, because for me, it's everything I've learned on the job. And so I hope to share some of that knowledge and insight with you all. Here's what the agenda looks like. I'm going to go over the ingredients for what I'm going to talk about and the tool that I built. Go over the implementation, the training data, the features, kind of what the machine learning lifecycle looks like, some accuracy metrics from the data that I have, and then we'll circle back with that demonstration. And then hopefully we have some time for Q&A. For my awareness of the audience, if you could just raise your hand, are you familiar with the Certificate Transparency Log Network? Okay, great. And how many people have ever trained a predictive model? All right, great. So the Certificate Transparency Log Network is about open auditing and monitoring for the issuance of SSL certificates. And you might think, well, what on earth does this have to do with Twitter? And I think it's a good analogy. If you were to look for Mark Wahlberg on Twitter, you would search and you might find 30 different accounts. And your visual cue for which one is actually his account is that verification checkmark. And at Twitter, this isn't much of a problem because they presumably have a small team, and they are the only authority that is issuing those check marks. And conversely, when you look at SSL and securing HTTP connections, you've got hundreds of authorities that are assuming that kind of role. So imagine at Twitter, instead of having one small team, they said, hey, you know what? We're going to outsource this to 170 different groups, and when they publish those check marks, we don't really have a way to look and monitor and audit. And that is precisely the problem that we have with SSL certificates. It's what we use to validate identities for web servers. So what Google did was they have this project they started in 2013 for monitoring and auditing, and occasionally you have certificate authorities that get popped or mistakenly issue subordinate certificates. So that's what this is all about. An extension of that, there's a group called Calidog Security that published a Python-based library that monitors this feed. So I haven't looked at the nitty-gritty details of how it works, but for me, I really like doing prototyping in Python, and you can just load this. It's in PyPy. So this is the data input to the predictive models that I built. And I've used scikit-learn, so it gets along very nicely. And then the third component here is with phishing attacks. So the trend is very clear. This graphic is from a group called Phish Labs, and If that's not exponential, I don't know what is. But this is the rate of phishing attacks that are conducted via HTTPS. And part of the problem is, like, we used to have a lot of exploit kits, we still have some today, but the sophistication for that is much higher than phishing. You know, you can get a domain name for free from certain top-level domain registrars, you can get an SSL certificate for free, and you can probably get hosting for free. So this is a very cheap attack, and in most security programs, people will agree that humans are the weakest link. So this is a trend, again, for me that's really important, because if more phishing attacks are being conducted via HTTPS, they need an SSL certificate, and if I'm looking at that log network, I can kind of see when they're getting their certificates issued or renewed. A couple months ago, and this is what inspired me to build this project. This was in November. There's a security researcher, he's anonymous, who goes by the name XORs. And you can see it's kind of a key, I took a couple things here. There are some keywords that assign arbitrary weights to different things. So in this domain name, if you see PayPal or MoneyGram or Morgan Stanley, give it this number. And then if it's over a certain threshold, then it's in bold and red. Otherwise, it's you can log it somewhere else. And I immediately, when I saw this, I said, hey, if I had been provided this project and he didn't give me any of these scores, if they were all blank, how would I know what the optimal score is? And is there a way that I can prove this? Because from my end, I've got two things. I know how to characterize what a phishing domain looks like. And we've got training data, like we've got historical examples of phishing attacks. So I immediately thought, like, hey, maybe the score of 70 should actually be 64. Or maybe these keywords are unnecessary. Or maybe these ones are really good and should have a higher weight. And then another thing that he looked at is looking at Levenstein distances, which is a similarity between one string and another. And I looked at this, for machine learning. Do we have the training data? Yes. Can I characterize, for some of these, not all phishing domains have blatantly obvious characteristics in the domain, but for a lot of what I'm looking for, especially from that feed, I do. So I thought, let's try to build a predictive model. A little bit of background on supervised learning. So we're going to start in the top, it'll be top left. So the training and text, that is libraries of domain names. So I've got a few, these are actually fully qualified domain names, so api.support.microsoft.com. You see the third one looks really suspicious. So that's the training data. The labels, it's for me this is binary. It's either uncharacterized, it's normal, or it's phishing. So I've got training data, and beneath that I've got labels. And the feature vector is just a fancy way to describe the characteristics that make up that domain. How do you describe home.pavpal country, some random domain.com? You'd say there's one dash, there's 3 periods. One of the words is, they're probably trying to make it look like pavpal. And that's what your feature vector is. So each one of these records is a domain from my training set. And if the label is 0, that means that's benign, and those are the characteristics that make that up. So when you train a predictive model, it's not like magic. You throw a list of domains at it and it returns phishing or not phishing. It actually doesn't even see that. It is taking your characteristics of how you describe that with a label. And all it does is it uses its algorithm, this component of what's the optimal score, that's what it computes for you. But it requires those characteristics and the training data. So what I've done with this project is I built my predictive model, and this new text, this kind of workflow that we're seeing in the feature vector, that would be the cert stream feed. So it's saying my knowledge, all the training data I have, what I think looks like phishing, it's building a classifier, and then I'm hooking that onto that feed. And ideally, what I need for it to be effective is my training data must be representative of what that feed is spitting out the whole time. Otherwise, you have a lot of noise. So I'm going to go into the implementation here. There are a couple different definitions of what the machine learning lifecycle looks like. Of course, it depends on if you're doing supervised modeling or unsupervised modeling where you don't have labels and you're just normally distributing and trying to find anomalous or extreme deviations from normal. So for me, I'm going to start in the top right. I have this idea. I think I can build a predictive model. I know where to get it. I've got some ideas of how to normalize it, which is really important too. So if it takes URLs, if it takes fully qualified domain names, if it takes just domain names, I have to normalize that or it's going to throw off my classifier. Then I'm going to explore different features, and I'll go through all of that. I'm going to extract them. I might engineer a few things. I'm going to select an algorithm and make sure that I select the right parameters for said algorithm. And then I'm going to evaluate. And this is very much iterative. There were lots of oversights I had. For example, I was looking for keywords account and services, or service. And then when I ran this on SearchStream, of course, it's tax season. I would flag everything that was accounting services dot whatever. So data acquisition, I took a number of different things. That security researcher who had his project, I took a few of those keywords. I looked at, there was another researcher, Swift on security, who has published some phishing regex for Exchange. There were some good words there, I thought. And then I looked at PhishTank, which is a resource for phishing domains, and looked at the top Alexa domains. Those are the most popular domains. And that doesn't mean that just because it's in Alexa, it doesn't mean it's not malicious. But specifically, I'm looking for like brand new phishing domains, and it's highly unlikely that that's going to end up in the top Alexa. And even if it is, if it's only a handful, I might be able to generalize enough with my classifier to detect them. And then again, it's very iterative. The data that I used ultimately were from doing the model corrections from my false positives. As far as features, I took 800,000 different domain names. I got it to 170,000 that I thought were definitely phishing. And I looked at, I split them by special characters. So if you can see, the screen is probably large enough. I just did a regex and I split on the /W. And it said every special character, whether it be a period or a dash or whatever, appended to this list. And I had this massive list. And then I used this collections from the counter library, and I just said, show me the most common. Now, what I should have done is filtered out the top-level domains, but that's a very long list. And I saw probably 300 that were really suitable for, when I see that, that's a good indication that it might be phishing. So that's kind of where I got about 100 or so. And again, it's extensible, the platform. You can add whichever ones you want. Maybe I missed some. Next was looking at popular brands, and this was really eye-opening. Fortunately, PhishTank already has this search where you can look by targeted brands, so I didn't think to look for things like GitHub or Dropbox. I just thought the defaults like Apple and PayPal. So there were about 30 brands there, some banks that I hadn't thought of either. And I cherry-picked them from this list. I added a few of my own. Gmail is a pretty popular one. And then I searched through, again, the 700,000 or so domains that I had from the regex and keyword search. That's completely uncharacterized data, but it gives me some corpus to look through to try to find data for my predictive model. And this one's really important, and it's really neat. It's also very simple, looking at Levenstein distances from phishing words. Again, this is a measure of similarity between two strings. So I don't have signatures for these two examples on the top right. I know when I see that, though, that that's definitely they're trying to make it look like Apple ID, or they're trying to make it look like PayPal. But again, if I search for only PayPal or Apple ID, I'm going to miss those every single time. So what I'm looking at is saying, for this list of keywords, I'm seeding it with like PayPal, Chase Bank, HSBC, things like that. Take all of the domains, split it by those special characters, and compute the Levenstein distance and see what it is. So if it's 1, that's again, these are on the right-hand side. These all have a distance of 1 from PayPal and Apple ID. This is also a really helpful utility for typo squatting. So if you type, instead of ESPN.com, you miss the O, that is registered and owned by some threat actors that redirect you to exploit kit landing pages. So it's something that I leverage for this utility. Another one is looking at targeted brands and specifically the placement of them. Are they the second level domain, or are they a subdomain on a different domain? And this is something that, again, encapsulates my tuition, and I can write this in a few lines of Python. So on the left-hand side, we've got some benign data where the brand is for example, Microsoft.com. So those are ones that I actually flagged initially, and this was before I started looking at the second level domain being one of 30 or 40 really popular brands. Conversely, when you look at phishing, this is a huge distinction of having Apple.com as a host on a different domain. And again, that's a feature that I can look for in my predictive model. A few other things, I looked at the top-level domains. These are things like com and org and net, TK and ML and lots more. And I extracted those and I used them as categorical features. I also looked at the number of dashes and the number of periods and the domain entropy, which kind of calculates if it's random or if it has repeating characters, it'll generally have a higher entropy. And again, I have an IPython notebook that walks through every single one of these. As far as the algorithm, I use logistic regression, and some would argue that this is hardly even machine learning, it's more advanced statistics. For me, if I wanted to use random forest, it's a one-line code change. And I just like this because it's very fast to predict, it's very fast to train, and again, it gives me exactly what I'm looking for. So what the algorithm does is based on my feature set, my descriptions, and the training data I have, it will compute the feature weight. So it computes the feature weight and the offset. I just give it the feature. So for each feature, it has a weight. And one of the things that's nice about this is after you train the model, each feature gets a coefficient, which is like the strength of whether it's more likely to be in a positive class or in the negative class. And what you'll see is on the blue ticks in this histogram, those are really strong identifiers of phishing. So you'll see Bank of America brand in the subdomain. I think we would all agree if you saw that and then some random, that's probably phishing. It had a PayPal Levenstein distance of 1. That's also a good indicator, and a few others. On the other side, if the top-level domain is com, if the accounting service keyword is there, that's also a really important characteristic. And if the PayPal brand is in the second-level domain, that's also important. So the other thing is that especially with neural nets, it's really difficult to visually kind of interpret why the classifier is doing what it's doing. And this is a simple enough problem where I can use logistic regression. The features I had were really good, and the data I had was great as well. So when I was swapping different algorithms, they didn't really make a difference, and I liked using this to visually kind of understand what it was doing. Now, another point here is that just because these have really high weights doesn't mean that that is definitively like the benchmark globally. That is merely a representation of my training data. So if I have all of the Bank of America brand subdomains in my training set, like that's going to be the highest. But maybe it's actually something else, but I don't have that in my training set. At least I don't have all those examples in my training set. And that's what 80%, 90% of what data scientists spend their time doing is getting training data that reflects the real world, especially when you're doing deployments with customers that have very dynamic data streams, they have different traffic profiles. Getting data that represents their environment is incredibly difficult. And again, this is what's so critically important. And this going back to that keyword tool where it had 70 and 60 and 45, I don't have to do that. I just have to say, here's how I look at phishing domains, and here are some examples. And that's something I think that's really powerful. As a security analyst, the ability to generalize at scale, that's what supervised machine learning can offer. And even though, again, this is a very simple model, it doesn't mean it's not impactful, I think. There are lots of metrics for measuring performance. So I think I'll go over this in the notebook again, but the confusion matrix, despite the name, it's not confusing, it's pretty simple. This kind of shows me my misclassifications. So when I'm taking all my training data and I'm splitting into like a training set, and then I leave a little bit out to do testing. And this is showing the performance of that classifier against the test set. And what's good is I have 1 false positive and I've got 6 false negatives. And largely I'm getting the classifications perfect. When it's actually phishing, it says it's phishing. And when it's actually benign, it predicts it as benign. And again, I'm not using any rules or signatures or things like that. So with that, let's jump back into the demo. So we'll pivot back to the command line, and this is great. So this was running again the whole time. If you take a look at some of those names, I think we can all agree I don't even have to do some kind of dynamic analysis. Every single one of these here, unlock, update account, information.cf, I didn't have a signature for that. I just had keywords and some ways to characterize it. And you can look at a bunch more: account, Apple ID, locked, verif.com, -com.tk. So this is kind of what the command line tool does. It writes it to a text file on disk. I didn't want to boil the ocean. I get lots of questions of, I'm not even honestly looking at the issuing CA. I think there's a trend. You'll see a lot of the suspicious ones are from Let's Encrypt. You could extend the model to also take that into account, and I'm not. I think the idea here was just to give some introduction, some background on how this works and the different independent variables that make up the classifier. And to give you some idea of what the search stream looks like, I've seen anywhere from 1,000 to 5,000 domains per second. So on the opposite side, it takes a few seconds to fire up, but these are all the domains that my classifier is analyzing. And on the left-hand side, those are the only ones it's flagging. So it's, if it were my job to go look through this list of this fire hose and find the phishing domains, I'd walk out of the door. Or I would just train a predictive model that did this, tell them I'm working 8 hours a day, and that's that. So I'll stop that. Actually, I'll pivot back a little bit more into the command line tool. So this is it. Everything is self-contained. I've packaged all of my training data. You can train your predictive models from the command line. You can view, you can manage them. So they're binary objects. So when you train multiple classifiers, it's important that if you swap them, you have to be able to extract the same features that were used at training. So if I start with one classifier that looks at 10 features, and then I add more, and then 20, and then 30, and then 40, and then I want to revert back to the first classifier, I have to have the code, the same feature vector from when I trained as when I'm deploying. So again, everything's Dockerized. I have a database that stores those objects in its own container. I have this command line tool that runs in its own, and the Jupyter Notebook runs in its own container as well. And I've trained a couple classifiers here. I didn't deviate any of the features. I didn't change any of the training, but you can see some of what this looks like. I've got the true positive rate, false positive rate, area under the curve, things like that, test set accuracy, the size of the feature vector. Again, this is identical, but as you extend this or explore and look at maybe you've got some ideas of better keywords or better features or better training data, you can continuously increment, and all of that, the data, the features is being persisted, so you can swap them and use them at your own consent. And that's, again, a lot of what data scientists do in Zeppelin notebooks or in Jupyter notebooks. Here you can drive it in the command line, and if you haven't used Docker containers, this is my first kind of exposure to using them for development. It's fantastic. I really like it, and it's built in Python 3, and I understand everyone has different environments. Maybe you have a MacBook, maybe you have Windows, different flavors of Linux. So if you have Docker and Docker Compose, you can run it anywhere. I use Linux. This is a System76 laptop. I usually have virtual private servers in DigitalOcean, and I have an install script that runs perfectly. And when I pushed this code on Saturday, I had my friend check on his MacBook, and he just said Docker Compose up, and then it was running. So that's pretty neat. A couple examples of what we saw from you could cherry pick pretty much any of those. Here are a few examples of what I flagged. PayPal support, verif, case ID, whatever. And when I hit it from a honey client, I got a 403 forbidden error. And I spoofed the user agent and refer and things like that, and then I got it to download. But these are things that people are using. So dynamic analysis would not have necessarily worked for me. And then I put it in VirusTotal for whatever it's worth. A lot of the engines, it's not the complete product, and especially with phishing, they'll probably catch it, but maybe there's a delay. For me as a threat researcher, it's one of the lower hanging. I've got lots of other utilities I prefer to use when I'm really doing a threat analysis. And then on the bottom right-hand side, here's the sandbox where I got it to work. I had actually found this on the same day. This was December 28th, 2017, when I submitted this talk. And this is the certificate that was issued to that domain that day, and you can see behind the screen is a PayPal login. Another one that I found a lot of is phishing kits. I found hundreds. So I haven't built a system that can that automatically queries to go hit those websites and do some directory crawling and fetch zip archives, but I found, again, a few hundred. And here's one that I pulled. When I went to the website, you can see the index of directory listing, and I found a zip archive. And then I took that, and one of the first things I did is I sent it to VirusTotal, and one of the vendors said it's got a web shell, and then when I looked at it, again, you can see it takes your credentials and sends them to whoever the attacker is at their email address. Again, this is not a unicorn, it's not magic, it's not a silver bullet. There are plenty of ways to bypass this. One example is international characters. So they look different, for the characters that I have, UTF-8. That's something that I need to take into account. Another one is if you're looking at URLs, my classifier, the data input is only fully qualified domain names. And I can very easily extend that to look at URLs. But at the moment, if you were to take this and run it in production or something, if there are attributes in the URI, which a lot of times I see, if you look at, there's a researcher, Illegal Fawn, on Twitter who posts URLs every day, and there are lots of characteristics that I see in the URI that my classifier is not looking at, so that wouldn't help. Another for the deployment that I have here is if you're not getting an SSL certificate, I'm not going to see that domain, and then I'm not even going to analyze it. So that's something to take into account. I think a really good use of a tool like this would be in like a DNS service. So rather than I've got a tool that's pretty proactive, and rather than reactively chasing these alerts, it would be nice if, again, because I'm doing this so quickly, on the DNS lookup, you would have the fully qualified domain name, and that would be a pretty good implementation. Another one that's really important is that a lot of the fully qualified domain names come from Let's Encrypt, and they enabled wildcard certificate support last month. So it was due in January, and it was pushed to March, and now it's live. And I thought I was going to see a pretty good drop-off in the number of phishing domains, but as you saw, we can pivot back. There were several that we saw up here. So I haven't seen that. You can see a lot of these are like PayPal, com, admin, refund, mandatory.gq. The wildcard cert would change that, where it would be star.admin, refund, mandatory.gq. And I would still probably catch that, but it's just something to be mindful of. And then the biggest part is that my recall rate is unknown. And I'll go through the Jupyter Notebook in just a moment. And out of all of the domains that are in CertStream, I don't know, I'm not doing ground truth on every single one. So I don't know how many I'm missing, but I know my precision is very high because it's manageable. With regards to let's see, here's what the Jupyter Notebook looks like. So it runs as its own Docker container. When you bring it up, you just look at port 9000 on that server. And I walk through everything in as much detail as I can. What's really nice about this is I can interweave text with code, and then you can literally just run this. And you can go all the way down. It's very detailed, and it explains the features I'm using and the code that supports that. And then at the end, again, some of the features, how categorical features work, the training of the classifier. You can view the performance metrics, and these are some of the metrics that you saw on my slide deck as well. And more detail on the precision and recall and true positive and false positive rate. I'd encourage you to check it out. If you have any questions, if things don't make sense, just reach out and let me know. It's available on GitHub at this link. I'll leave this up for just a moment. I pushed it on Saturday, and again, everything's available there. I've got the training data. I've got 3 different folders for my containers, and there's a lot of things that you could do with this. I'm not even looking at the IP addresses that I'm resolving. I could look at hosting providers. I could look at passive DNS. I could actually hit the websites, pull down HTML, do bag of words, create a second classifier. You could go crazy. So what I was trying to do here is be like, here's a very simple example of how predictive modeling works. So if you have an example where you're drowning in data and you're there's a lot of talk, especially again this week at RSA, of machine learning and AI solving everyone's problems and this technology from the future that marks the beginning of the end for the human race. Maybe you can hit the marketing guy, well, what's the precision and recall rate looks like? Where did you get your training data? What kind of features are you extracting? And then he'll probably forward you to the data science and team, and that's who you really want to talk to. And I think that's everything I had. I'm light on time, but I hope you enjoyed it. If you think I'm stupid, you think I'm a genius, you want to buy me a beer, I'll be here this week. And thank you very much.